Shapes of molecules, A-level chemistry. One of the very common questions in your A-level exam is shapes of molecules. So you need to know that the shape of any molecule will depend on the number of bonds and the number of lone pair of electrons around the central atom. The electron pairs around the central atom will act as charged clouds which repel each other. So if you look at this molecule of ammonia, we're going to see that there are four different electron pairs, and these electron pairs represent charged clouds. Three of these are bonded, an covalent bond between the nitrogen and hydrogen, and just one of these is a lone pair of electron. The lone pair of electron are these two electrons which are not contributing in a covalent bond. So the main idea here is to keep the electrons as far as possible in space due to the repulsion between these charged clouds. The repulsive force between the lone pair and lone pair is greater than the repulsive force between the lone pair of electrons and the bonded pair, which is greater than the repulsive force between the bonded pair and the bonded pair. And that what makes the shape of the molecule. So you need to know exactly how many bonded pairs are there and how many lone pairs are there in the shape in order to predict the shape of the molecule. So you need to note that when you draw the shape of the molecule, because we are drawing a 3D shape, you need to pay attention to the wedged bonds, which are the bonds which are sticking out of the beige going towards you, and the broken line bonds, which are the bonds which are going into the beige or from behind. This is because we are representing 3D structure. So if we imagine we are looking at this molecule of methane, then this wedged bond here, the between carbon and hydrogen, this is the one that is sticking out of the beige towards your eye or towards you. These two bonds here, the normal line ones, these are the ones at the plane of the beige. And then this broken line bond here is the one that goes into the beige or from behind. This is the one that is behind what you are, where you are looking. So when you try to predict the shape of any molecule, you need first to memorize the different shapes based on the number of electron pairs, the number of bonds, and the number of lone pairs. So if you have two electron pairs, something like beryllium dichloride, there are two bonds, no lone pair, then the shape is going to be linear with a bond angle of 180 degrees. In this case, this is the furthest away these two bonds or these two bonded pairs can be as furthest away from each other in space. So it's linear with 180 degrees. If you have three electron pair, something like boron trifluoride with no lone pair, then the shape is going to be trigonal planar with a bond angle of 120. So all of these are 120 degrees. This is the furthest away all of these can be from each other in space. And then if you have four different electron pair, you have three possibilities. Either you have four bonds with no lone pair, and this is something like ammonium ion or something like methane, then the shape is going to be tetrahedral. And this is a 3D shape now. This is not planar, and the bond angle is 109.5 degree. This is why we are drawing one bond in this wedged bond, and one is the broken line, which are the ones to represent the 3D shape. And then if you have three bonds and one lone pair, the shape is going to be called a trigonal pyramidal, and the bond angle is 107. This is something like ammonia, which has this one lone pair of electron. The bond angle here is less than the ammonium because the repulsive force between the lone pair of electrons and the bonded pair is greater than the repulsion between the bonded pairs together. So they are pushed a bit into the inside. This is why the bond angle is smaller here, is 107. Again, we are drawing a 3D shape, and then we are using these two bonds, the widget and the broken line bond. The third possibility for four different electron pairs, are having two bonds and two lone pairs of electron, like water. Water has two bonds and two lone pair of electrons. In this case, the shape is called bent, or we can call it also V shape. The bond angle here is even less, it's 104.5 degrees. The reason for that is because of the repulsion between the two lone pairs is greater than the repulsion between the lone pair and the bonded pair, which is greater than the repulsion between the bonded pair and the bonded pair. So again, these two bonded pair are pushed to the inside and the bond angle is smaller. Then if we have five different electron pairs, then we have three possibilities as well. The first one having five bonds, no lone pair. The shape is called a trigonal bipyramidal, like phosphorus pentachloride. The bond angle is going to be two different bond angle. The first one is 90 degrees and the second one is 120 degrees. Remember, when you draw something like that with the five bonds with no lone pair, three bonds will be in the same plane as your paper, just the lines, and one is sticking out and one is sticking towards you. So one is wedge and one is the broken line. The second possibility is having three bonds and two lone pair of electrons. In this case, the shape is called T-shaped. And here, when you draw the T-shaped, even though it's a T-shaped and they still have the three bonds in the same plane as the paper, but the bond angle has become a bit smaller. It's not 90 now, it's 88 degree. Remember that the repulsion between the two lone pairs pushed the bonds a bit into the inside, so the bond angle now is slightly smaller. The third possibility for having five different electron pair is having four bonds and one lone pair. In this case, the shape is called seesaw, and there are two different bond angles. The first one is 87 degrees, and the second one is 102 degrees. In this case, you still gonna draw the 3D shape, and it's a seesaw. So basically, one of the bonds is going to be the wedged bond, and one of them is going to be the broken line bond. The last one is having six electron pair, and we have two possibilities. The first one having six bonds with no lone pair, then the shape is called octahedral, and all the bond angles here are 90 degrees. When you draw this shape, two bonds are going to be the line bonds, two bonds are going to be the wedged ones, and two bonds are going to be the broken lines. And finally, you can have four bonds, two lone pairs. In this case, the shape is called square planar and the bond angle is 90. We have two lone pairs here and we have two bonds which are sticking towards you with the wedged bond, and two bonds we draw them with the broken line. So in your exam, they will ask you to predict the shape of certain molecules and compare between them. So how can you predict the shape of any molecules? Always remember that the shape of molecules will depend on the number of bonds and the number of lone pair of electrons around the central atom. So to work out to predict the shape of molecule, you need to go through certain steps. First, you need to work out the central atom, and then you need to work out how many outer shells electrons are there with this central atoms by looking at the periodic table and see where it lies in terms of which group in the periodic table. And then you add one extra electron for each bond that we can see in that structure. And then we divide that total by 2 in order to find how many electron pairs are there. And then you subtract that the electron pair, the number of electron pairs, from the total number of bonds. That should give you the number of lone pairs. So let's have an example. So if you ask you to predict the shape of H2O, H2S. Then first of all, the central atom here is the sulfur, and sulfur is in group 6 in the periodic table, so there are 6 outer shell electrons. There are 2 bonds because H2S, and so we add these 2 electrons to the 6, so in total there are 8 electrons now. So 8 is divided by 2, that will give you 4, so there are 4 electron pairs, and there are 2 bonded pairs because there are 2 bonds, which means there are 2 lone pairs. So now we have 4 electron pairs, 2 bonded ones, and 2 lone pairs. So the shape is going to be the bent or the V shape with a bond angle of 104.5. So this is the shape of H2S.